2, 1. All right, so solving linear inequalities. My assumption in this video is going to be that you have solved equalities at some point. And I have done huge amounts of videos on that. So I'll put up maybe a link to a playlist if you want to refresh yourself on solving equalities. So here is one equality that we have. And before I get into inequalities, and I'll explain the linear concept first, because if you're solving unlinear ones, it's a much different ball game. Now, my goal here is going to be to try to show you kind of the subtle little difference between the inequality and equalities when you're dealing with kind of linear left-hand sides and linear right-hand side. Now, what do I mean first by linear? So what I will mean is I'm going to try this equality right here, and then I'm going to walk through some concepts. So what I'm referring to when I say linear is that if we have the left-hand side right here, you're going to be able to take the left-hand side and then simplify it such that it's going to look in the form of basically a line. So mx, let's say, plus b. And for those who may remember, so this is just nothing else but simply the slope and y-intercept form of a line. Now, the right-hand side, we're going to make the same assumption. So maybe what I should do is maybe I'll call this M1 and B1. Okay, so, or M maybe L for the left-hand side and B subscript L for the left-hand side. Now, on the right-hand side, I'm going to make the same assumption. I'm going to make the assumption that I can take the right-hand side, and for it to be linear, what I can do is I can simplify this in such a way so that, again, it will look in this format where I'm going to have the slope of the right-hand side times then x plus the y-intercept, okay, of the right-hand side. So maybe I'll put an r right there. And again, that is just simply in slope and y-intercept form. So what I'm trying to do is I'm trying to have a line on the left-hand side and then a line on the right-hand side, and I'm going to equate them. If we have this style, okay, where the left-hand side equals right-hand side, and you have a line on the left-hand side and a line on the right-hand side, then really what you're solving for is you're solving for the point of intersection of that line. Okay, so where do they intersect? At what x value will they actually intersect? And I'm going to do that, okay, to show you, because I think it will bring a nice concept towards the inequalities for us as well. So if I take the right-hand side, and I'm going to simplify this, I'm going to distribute across. I'm going to get 3x plus 6 minus x. And this will just simply collecting like terms. So these like terms right here, I'm going to get 2x plus 6. And overall, so what I have is, instead of what I originally started with, I have this line is equal to this line right here. And what I'm going to be doing is I'm going to try to see, okay, so where do these two lines actually intersect? All right. Now, if I would plot this on decimals, okay, so let's say I'm going to bring out decimals right here for us so that we can see this. I'm going to plot these. So I have one line, so y, I'm going to put it as y is equal to negative 2x plus 4. So notice that's the left-hand side. And then my right-hand side, so I have that right there. And I can zoom in here. And I will find exactly where they intersect. So they intersect this particular point. So the value of x where they intersect is really just negative 0.5, right? Now we get a resultant y as well because we plotted them as a line. And now if I would solve this, okay, throughout, it will be something that you should be familiar with. And what you would do is you would simply say, okay, so let me collect and bring all the x's together, and let's take all the numbers, okay, and bring those together. Okay, so these are basically just collecting my like terms. So I would do something like this, and I would get negative 4x is equal to, and this would have been just 2. Now dividing this by negative 4 on both sides, and I am able to solve Okay, and this is indeed going to be negative 1 over 2, or just simply negative 0.5. So I've solved this. And what that would mean is if I would substitute it to my original equation, it would make the left-hand side equal to right-hand side. You know, you can try that on your own. So that isn't anything new. And you might say, well, I thought you were going to talk about linear inequalities. But I wanted to bring this back, this concept back, and then relate it to lines in a particular way, so that really what you have is you have one line on the left-hand side and then one line on the right-hand side. Now, what's the difference if I would do kind of inequalities? So let me borrow this right here. I'm going to take this entire thing. Okay, so let me borrow it. So I'm going to copy this and bring it down right there. This is what I have. And now for inequalities, what we mean that this sign is no longer an equality. So what this could be is, it could be, for instance, less than. It could be less than or equal to. It could be greater than, or it can be greater or equal to. So these are the 4 inequalities that you might run into. Now, it doesn't really change your left-hand side and right-hand side. Now, in simplified form, because we've already done this, so we know that on the left-hand side, so this was already a line, and then on the right-hand side, I guess this was 2x plus the 6, right? So that was the simplified form of this right here. So if you throw in an inequality, okay, so for instance, if I did have, so something like this right there, okay, and I have that less than sign, then what it's asking me is basically, okay, when does the line on the left-hand side is actually smaller or equal to the line on the right-hand side, right? So I can do that. And I can certainly try to plot it on decimals and then see, okay, when this is true. And I'm going to do that for you in just a moment. Now, before I do this, when we were solving equalities basically, okay, comes down to one of the following few steps. So you basically simplify. So that was our step 1. So you can simplify your left-hand side and you can simplify your right-hand side, and you can put them into the form of, you know, your mx plus b. So this is, again, just assumption that it's linear. So we don't have any variables in the denominators. You know, we don't have any variables that have a power of 2 or a square root or anything like that. All right. So that's the first step. So simplification. That will not change when you're solving inequalities. So you basically will be solving these inequalities by putting it into this mx plus b form. Okay, so that would have been the first step. Now, what else do we do when we solve these? Well, what we did was we started to collect like terms, right? So we would try to move terms. So we would move terms to the left-hand side or the right-hand side. And that was this step right here, where we basically just shifted over this 4 to the right-hand side, and then this 2x to the left-hand side. And now what happened? Well, what happened was the sign changed on us. So really what we were doing when we're moving that 4, we're kind of subtracting negative 4 from both sides. And then when we are moving the 2x, we are subtracting negative 2x from both sides. So this moving of terms is really nothing else but simply the addition or the subtraction of terms. Now, when you have an inequality, you can also do that. You can move terms around. And now, let me kind of bring something of importance to you. Now, let's just start with just basic numbers here. If I have a number, so let's say if I have an inequality, and let's say I have 4, and we know that 4, let's say, is greater than 2. Now, if I'm going to be adding, or if I'm going to be subtracting something from the left-hand side and the right-hand side, does this change the inequality in any way? Now, when we're doing equalities, we know that adding the same thing to the left-hand side and the right-hand side will not change the equality. So that's why we can move the terms around. But now here, can we move the terms around freely without changing the inequality in any way? So if I take a 4 and I'm going to add some number, now let me just add a number, let's say like 2, okay? And here I'm going to add the number like 2 as well on the right-hand side, okay? Would this change anything? Well, it won't really change the inequality, because what we're doing is we're just shifting the numbers over by 2, right? Because we've added 2. So what I would have is, as a result, so I have 6 is still greater than 4. So it hasn't changed my inequality in any way if I'm going to be adding. Now, what if I subtracted, right? What if I subtracted a term? So here, instead of adding, so what I will do is, what if I subtracted? Does this change anything? Well, just like the addition, it won't change, because what it's doing now, it's just shifting the numbers to the left, right? It's making them smaller. So in here, what we would have is, then this would simply be that I have 2, and then here this would have been just a 0. So that is still, 2 is still greater than 0. So it turns out that when you move a term, which really means you're adding or subtracting to the left and the right hand side, nothing changes. So our inequalities still hold. So we can move terms around without worrying about changing the inequalities around. Now, what if, okay, the last step, because in the last step, what do we do in order to solve for our equations? Well, our last step was, after we move our terms, we would then divide or multiply. Okay, so in this case, we divided by -4 to isolate for our unknown. That was in our equations, and we didn't really think much. We just got our answer. In this case, it was -0.5. Now, inequalities and equalities, that doesn't change anything. But what about inequalities? All right, so let's go back. So now the last thing is we're going to either multiply or we're going to divide, okay, both sides to isolate for our unknown. That's what we have to do. So let's take a look. If I had, okay, so my original, let's say if I had 4, and this is, greater than 2. What if I would divide, okay, let's first take positive numbers, okay? What if I divide or multiply by a positive number? All right, so let's say if I multiplied, and I'm going to start with 2. If I multiply this by a positive number, okay, so I have to do that to both sides, what would happen? Well, so this would turn into an 8, and this would turn into a 4. So what happens is it just gets scaled, right? So your inequality would just simply get scaled, but 8 is still greater than 4. So that's not a problem at all. Now, let's take a look if you multiplied. By now you multiplied by a negative number. If you multiply by a negative number, look what happens. Now you have to be careful, because this is a little bit different than your equalities. If you multiply by a negative number, all of a sudden, I get -8, and here I get -4. And now, look what happens. Wait a minute. -8 is not greater than -4. So what that means is that if you have an inequality and you're multiplying by a negative number, you actually are now changing your inequality. So what you have to do is you're going to have to switch your inequality around. So whenever you're multiplying by a negative, and the same thing is true actually when you're dividing by a negative, then your inequality will change. It will switch sides, because of the fact that now you're bringing in negatives. All right? And you can see that directly through this very simple example, but this is also true for your inequalities in general. So whenever you have a negative and you're going to multiply both sides or divide both sides by a negative, you're going to have to switch, okay, and swap your inequality in this particular way. Because now, okay, that is true, but this clearly is not true. So this is different than equalities, because when we had equalities, we didn't have to worry about this at all. Because if you multiplied or divided by a negative, they were still equal because they started off as equal. But in here, they're not starting off as equal. They're starting as an inequality. So be careful. And that's the one little difference between solving equalities that are linear and solving inequalities that are linear. All right? But the overall steps, okay, are the same. So if I take my original right here, so let's say I'm going to take this, okay, let me copy this down and paste it. So if I have this, let me remove the yellow. So my first step is I'm going to simplify just as I normally would. All right, so that is no difference. So I have on the left-hand side basically a line, and on the right-hand side I have some kind of a line as well. Now, the next thing is I move my terms around. Moving terms doesn't change anything. So if I bring this over or bring this over, it doesn't change my inequality. It will stay the same. So this is going to be negative 2x minus 2x, so it's still less than or equal to 6 minus 4. That is not a problem. So first simplify, now move terms. Now finally, so I can collect my like terms. So this still stays the same. But now, in order to solve for my x, notice that I'm going to have to divide by a negative 4. So if I divide this by negative 4, and this by negative 4, then what happens is that my sign, my inequality, has to switch. So in this case, once you do that, okay, you're going to switch your inequality. This will become x, and this is negative 0.5, or simply negative 1 over 2. Now, I'm going to show you this on decimals as well, okay? So if I go back here to decimals, here are my two lines, okay? Those are my original two lines. And now I'm going to put in the inequality, which we actually can do, which is great, okay, in decimals. So now what I'm going to just show you here on decimals is let's plot this inequality. So we can do that in decimals. So what we have is we have negative 2x plus 4, I guess was less than or equal to 2x plus 6. And look at that. So decimals actually shows us, so this what you see there in green on the right hand side, it shows you all the values for x that your line, so your red line, which is the 2x plus 6, is greater than your black line, which is negative 2x plus 4. So it actually literally shows you, and you can see that. So decimals does a wonderful job for us. And again, this visually actually tells you what these inequalities mean. When they're linear, you basically have two lines. You have a line on the left-hand side of the inequality and a line on the right-hand side of the inequality. So as we did right here. So here was my left-hand side. Here was my right-hand side. Okay, so that's what I saw there. And then what I have is when you map those two lines, you just want to check, okay, when does the right-hand side line is bigger or equal to? Now, sometimes, you don't have the less than or equal, you might run into, okay, so all of the different signs. So for instance, you can run into, so for instance, this or this. And when you plot these in decimals and when you typically see it, so if I go back here, let's say if I change this instead of making it, okay, equal, I would just make it less than. Notice that on decimals, you would see a dotted line or a dashed line, and that just means it doesn't include that number. So this is a wonderful introduction to solving these linear inequalities. So step 1, always simplify the left and the right hand side. Step 2, okay, is you move your terms around. Those 2 steps are no different than solving equalities. Step 3 is you're going to have to divide or multiply. If you're dividing or multiplying by a positive number, it will not change your inequality. It stays the same. But if you do that with a negative number, then unfortunately you have to switch the inequality around. And if you like, you can always go into decimals and plot it for yourself. All right? So that's the explanation that I have for you. Okay? And if you're going to be interested, I'm going to do a few examples like this, and maybe I'll link the video up above there. But for this video, okay, I'll end it here. Thanks for watching. See you in a future video.